Good morning, folks.
Hello once again.
Isn't it a little scary when you write code, and in this case, it didn't compile properly, so that was comforting. But then once you fixed your compile errors, everything just kind of works. I always become really suspicious, and then assume that there's more sinister things at work when things appear to work properly. Good morning, Josh. I was just telling the guys how I become really suspicious when things seem to work too well.
Yeah, it's always troubling.
It's like there's some sinister, karma that's going to come back and.
Yeah, it's like, is the test actually running my code or what?
Yeah, exactly. At least this time I had lots of compile failures, so that made me feel a little better. Because sometimes when you don't have anything and it all just kind of works, then you're really in trouble.
Yeah, exactly.
Good morning, Sage.
Good morning. Hmm. Not many people here today.
No, it's still sometimes we have people kind of show up a little bit late, but looks like a small crowd.
Yeah. We can focus on the. Let's see. So, just looking through the pull requests here. There's the Mon thing that Shashi identified with the OST mapping encoding. That one is almost ready to merge. We'll need to get backported to Luminous. Basically caches the re-encoded map, so you don't have to do it for every message. And see, I think the other one is Redislav has two pull requests trying to speed up the crypto stuff. One is adding a encrypt decrypt call that avoids bufferless, just works on pointers. But that helps currently with NSS, but partly just because it's NSS sucks. He has a bigger change that switches to OpenSSL that he's working on that I think is much more useful and promising. So I think we'll see what happens there. What else? Few random little things merged. The quick assist compression is almost, I think that's actually basically ready, but we're going to merge it after Mimic. Is that right, Josh? I can't remember.
Yeah, I think so.
Yeah, look. Or maybe it merged. Yeah, I think I'll just wait until after Mimic for that. Oh, there's the huge pages for BlueFS. Is that one ready? Yeah, I guess. Is that one ready to go?
It's reworked to get its separated buffer row implementation. However, I would like to put to squeeze also the cost of going to kernel to mmap each buffer with buffer recirculation. I guess it could be made CPU thread private, so we would even if we don't need some queue for garbage collection, maybe we could go even without any synchronization.
Yeah, it's I guess if we're only using this for the BlueFS buffer, then I don't think it's worth it because it's only like every couple of megabytes that there'd be a single syscall.
I took a look on profiling.
But
I can
sorry, go ahead.
see there is around 1.5% to squeeze.
Okay. Okay. Well, let's do it then. We just need to make sure that we'd have to put a limit on how many pages per thread. It's a thread local thing, because if you don't reuse it in the same thread, then you're just wasting memory.
Yep.
And you might get into a situation where the memory is always allocated in one thread and freed in another.
But I guess it's not the case of huge pages. We are using explicit huge pages that must be set explicitly by sysoperator. So even if we exhaust the pool, a fallback should take care of the situation. Of course, there will be performance degradation, but still, system should be usable.
Yeah, I just don't want to get a situation where we're like have a bunch of allocated but not being used pages sitting on a different thread's recirculation list.
Could we use our safe timer or something like that?
Maybe. For something this low level, it seems like it's not the right fit.
Basically, we could have some kind of a unique pointer with custom deleter to call munmap when object lives is over.
It seems like a simpler thing would just be to use like a spin lock for the recirc list. If that's faster than mmap, it makes this a simpler model. You could have like a fixed size buffer of like 5 huge pages or something.
Could work.
Shared across threads. Yeah. Anyway, I just don't want to do something overly complicated. If we can do something simple, that is good. Okay, but that'll be a post mimic thing too. That we maybe backport. I don't know that there's much else going on here. There's still the recovery optimization, but I think that's still not ready. Right, Josh?
Yeah, I'll probably ping on them on PR to see if they've got more fixes or what's up.
Okay. Okay. All right. I guess that's basically it. What else is going on? OpenSSL thing sounds pretty promising.
Sage, I think last week I wasn't here because I had a doctor's appointment, but I think there was a discussion regarding allocation and free list management. I think Igor has been working on some kind of new bitmap allocation idea that he has, and then Adam has been kind of looking at fragmentation in Yeah, in ours.
Yeah, you were mentioning he was thinking that we needed to make BlueFS allocate in smaller chunks to down to the min-alloc size. And that since this was primarily used for SSD workloads, this probably would not be an issue, he was thinking, in terms of the extra overhead.
Yeah, probably. I was just trying to keep it simple because the files that BlueFS writes are always big, almost always big. So, but maybe that's not actually true. I don't think it matters too much.
Yeah, I guess if we're getting fragmented that much, then it's probably not always true in every case. But
yeah,
I think that Igor and Adam were also suggesting we should try to gather some data for what the allocation patterns actually look like.
Yeah.
Maybe from like the lab cluster or something.
Yeah, that would be smart. At one point, Verado was looking at building like a simple test that would generate some like write workload, write delete pattern, and just simulate how the allocator would fragment over time. I don't know if you ever actually did that. It all kind of depends on what the simulated workload is, but then at least you could compare different allocators to see how they do in the limit without actually doing any IO, see how they fragment.
Yeah, that's a good idea. You can even generate those workloads based on traces from real workloads too.
Yeah, actually, yep. Yeah. Yep, okay. I don't know. I don't really have anything else to talk about. Any other topics we should cover?
Sage, over the course of kind of working on this cache balancing work, the kind of way that the BlueStore cache is set up is kind of, at least for me, not super intuitive, since you're passing in like ratios and I guess I'll just say it feels like we kind of are right now spreading out where we're computing ratios in the code, and we have some kind of determinations happening inside the cache and then outside the cache, and now almost also in the mempool thread where I'm doing things. I wonder a little bit if it would make sense to have the cache be trimmed more in terms of either just the number of O nodes or the number of bytes, rather than kind of trying to pass in the ratios and have it kind of figuring out based on kind of your target and ratios how much it should trim for the buffers versus the O nodes. If it would be more straightforward to have it be more explicit there.
I thought that's actually what it did. I thought the ratios just get multiplied out to get an actual number, and that's what we trimmed against.
Yeah, it is. And technically you can just call it's like a struct, so you can just call that anyway, but it's, like got an underscore to be kind of flagged that that's supposed to be the internal trim, rather than, using the trim interface, which has the, ratios specified. Maybe I don't know. Maybe it's not that big of a deal. But also right now we trim over the shards, right? The cache shards.
Yeah.
And I wonder if it would be nice to have something more like kind of a traditional, this is the cache and this is what you're trimming, to kind of, value.
I think if I remember correctly, the trick is that we trim metadata in terms of O nodes, but memory is consumed by like 10 different structures, but we only trim by O nodes, and so we have to like work backwards to the number of O nodes, and that's what we trim against. That's
sure.
I don't know. I'm not really. I think I'm not understanding what the problem is.
It's not really one, honestly. I mean, it's just the I guess the way that we kind of look at things right now with ratios is kind of
It's
a
awkward
little
because we
more.
have limits based on size. Like a min is
Yeah,
size, and so we have to back that into a ratio and then convert that
yeah.
to size. Yeah.
The whole thing just kind of feels a little convoluted or strange. I mean,
Yeah.
it's not that big of a deal. It's just something that kind of that gets leaked out to the user, right, where they're setting all these ratios and they've got weird things and people don't understand what they're doing really.
Yeah. I mean,
And
partly it's confusing if you know exactly how big you want each piece of the cache to be, but the goal was to simplify it so that there's one number that you set, which is how much memory is the OSD going to use.
yes.
And if you want that to work, then everything else has to be a ratio of that. So
The cache itself doesn't really need to. That doesn't need to be part of the cache interface, though, right? The cache interface can just be, here's what I want you to trim buffers to, and here's what I want you to trim, you know, O nodes to, maybe by the O node count, I guess. You could do it that way, which I think is exactly the internal trim.
Yeah, that's what it does. Yeah.
Interface. So we could just make that the thing that, take out any other smarts out of it, and then say that's the thing that's what you give it.
As a user, you mean?
As a, well, treating it like, as a developer, treating it like a black box, I guess.
Yeah.
The other thing I wonder a little bit about is how much advantage do we gain by having that as kind of the same interface, like both buffers and O nodes. Is there any real advantage to tying those two things together?
I mean, you could have underscore trim underscore O nodes and underscore trim underscore buffers. It's actually two separate chunks of that same function, but you always call them at the same time. So I'm not sure we gain anything by doing them.
I guess the way I'm kind of looking at it is, potentially we have lots of different caches. Maybe in the future we have even more than what we've got now. With RocksDB, we've got buffers in BlueStore, we've got O nodes in BlueStore. Maybe there's other things that we end up caching down the road. I don't know, but it would be kind of nice to be able to have like a common interface for all of these different things, where you say you want to set their capacities, you want to find out what their capacities are, you want to set maybe priorities for them, you want to trim them, maybe do other things too. It could be nice to have some kind of more unified interface for all of these.
Yeah. I think it's cosmetic though. At the end of the day, you set your policy in terms of how big you want them to be, and then if there's any actual value in being able to trim them individually, you can still just trim everything and force all the limits.
Sure.
So, I mean, we can shuffle the code around, but I don't think it actually buys us anything.
No, I don't think so either, other than right now I'm just kind of doing a little, not real wonky things, but a little bit of wonky things to kind of make it fit into the model I'm kind of making here. So anyway, it's not a big deal. Just this was
let me know when the PR is ready to look at. I'll take a look.
Sure.
I haven't looked at this in a while, so
sure.
All right. Is there anything else we should cover, or should we just go back to squashing mimic bugs?
Yeah, I don't think I've got anything.
All right. right. In that case, let's reclaim
Wrap it
40
up.
minutes of our day.
Sounds good.
All right. See you guys.
See ya.
See ya.
See you tomorrow. Bye. See you guys.